Hello students, today's lesson is on converting equations to slope-intercept form. So first we need to know what slope-intercept form looks like. Here is the equation for slope-intercept form. It's y equals mx plus b, where m represents your slope and b represents your y-intercept. So let's work a couple of problems converting to slope-intercept form. In problem 1, we have 12x plus 6y equals 18. So this goes along with the video that you watched the other day with the math teacher singing. You want to get your y alone. So that's the first thing we're going to do. So we need to move everything away from the y. So we're going to subtract the 12x over to the other side. That's going to make the 12x go away. So now we have 6y equals, you always want to write the x part first. So we're going to put negative 12x and then plus the 18. And now we have to get rid of the 6. We're going to do that by dividing by 6. And we're going to divide everything by 6. So we have y equals negative 2x plus 3. Okay, and now it says for us to sketch the graph. So we're going to draw a x and y axis over here. Now to do this, we need to write down what our slope and our y-intercept is. So if you remember from the equation, our m is our slope, and in this equation the negative 2 is in the place of the slope, so m is negative 2. And then our b, our y-intercept, is 3. Now, the way that I teach this is that we always want to start with the y-intercept when we graph. And so I say that b stands for begin. It's not really why we use b, but I just think it's a good way of remembering that you want to begin with the b, and then you're going to move with the slope. Now remember, slope is the same thing as rise over run, and because we have a whole number, negative 2, that means our rise is negative 2, but we assume that it's over 1. All whole numbers will be over 1, so the run is going to be 1. So we're going to begin with 3. So on our y-axis, at 3, we're going to put a point. And now we're going to rise negative 2, which means from this point we're going to go down 2, and we're going to run over 1, and so that would be right here. This point would be right here. So from the y-intercept, again, we went down 2 and to the right 1, and so now we can go ahead and connect the 2 points. So I'm going to just sketch a line. I know it's not perfect, but we're just trying to sketch it. Okay, so here is our slope-intercept equation, and then there is our graph. Problem number 2, we want to get y by itself, so let's subtract the 16x over to the other side. So we're going to have a negative 4y equals negative 16x plus 20. Let's divide by negative 4. We're going to do that everywhere. So this cancels, and we have y equals negative 16 divided by negative 4 is positive 4x, and then 20 divided by negative 4 is a negative 5, so we're going to put minus 5. So in this particular example, we have our slope being 4, and I'm going to go ahead and put 4 over 1. And then our y-intercept is at negative 5. So let's sketch the picture. So we've got our x and our y-axis. We are going to begin with the negative 5. So on the y-axis at negative 5, we're going to put our first point. And then we are going to use our slope, which is rise over run. So we're going to rise 4, So 1, 2, 3, 4, and go over to the right one. So it would be right here. And again, I can connect my points, and this is my line. So notice you always want to double check it, because in this particular one the slope is positive. And you want to make sure that you did it right. If you end up with a line that has a positive slope and you have a positive slope in the equation, then you probably did it right. Okay, in this next problem it is written in what's called point slope form. And again, we want to convert it to slope intercept, so we want to get the y by itself. So the first thing I'm going to do is I'm going to distribute the negative 2/3 to both parts of this parentheses. So I have y minus 10, and that equals, I'm going to have a negative 2/3 x, and then negative 2/3 times negative 6. Let me write this over here. I'm going to have a negative 2/3 times the negative 6. Now when you multiply fractions, this negative 6 is over 1. When we multiply fractions, we're going to multiply across, so straight across. So we're going to multiply the numerators, so negative 2 times negative 6 is a positive 12, and we're going to multiply the denominators. 3 times 1 is 3. And then we're going to simplify that, and so 12 divided by 3 is 4. So when I multiplied the negative 2/3 times the negative 6, I ended up with a plus 4. Now get your y by itself, so we want to add the 10 to the other side. We're going to add it to the 4 over here. It cancels. We have y equals negative 2/3 x plus 14. Okay, so let's go ahead and sketch our graph. It's at 14, so that's the b is at 14, so my slope is a negative 2/3, and my b is 14, so we have to start at 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Gotta keep on going. 11, 12, 13, 14. So that's way up here. I'm going to put a point right here. Okay, now one thing I want to point out is when you have a negative slope, only one of the numbers ends up negative. Now I generally just always make the top negative. Again, it's just, forms a habit if you do the same thing. So when you have a negative slope, it's not making both of the numbers negative, it's only one of the numbers that ends up being negative. So we're going to keep the negative on top with the 2. So we're going to start here, begin at 14, we're going to go down 2, and to the right 1, 2, 3. So again, down 2 and over 1, 2, 3. So it's going to be approximately right here. And you can go ahead and connect the dots. Ooh, that was terrible. But pretend like that I connected those dots. And that would be my line. So notice that it does have a negative slope. The line is going down. That is negative. And so it looks like we did it okay. Number 4. Let's go ahead and distribute the 4/3. So we have y plus 3 equals 4/3 x, and then 4/3 times a negative 2. We're going to put negative 2 over 1. So you multiply across, so multiply the top numbers, that would give you negative 8. Bottom numbers, 3 times 1 is 3. And we're going to go ahead and make this a mixed number. So 3 goes into negative 8 a negative 2 times, and with a remainder of 2, so I'm going to put 2 over my 3. Again, if you need to use a calculator to do that, you can. I made it a mixed number because I want to make sure I notice where it goes on my graph. So negative 2 and 2/3. So I need to get the y by itself, so I want to subtract 3. Okay, and then I have y equals 4/3 x, and then negative 2 and 2/3 minus 3, it would be a negative 5 and 2/3. Okay, so let's go ahead and graph this. We are going to begin with our b, which is negative 5 2/3. So 1, 2, 3, 4, 5. That's negative 5 2/3 would be almost to negative 6. And then we're going to rise 4 and run 3 because this is our slope. So we're going to rise 4, so 1, 2, 3, 4, and run 1, 2, 3. So that would be approximately right here. We're just sketching, and you go ahead and connect your dots, and there is your line. Okay, on these last two, I want you to try and do these on your own. So pause the video, work through them, and then when you're ready to check your answers, go ahead and hit play again. Okay, so on number 5, went ahead and solved for y, and hopefully this doesn't confuse you. The negative 9 divided by 6, that reduces to negative 3 over 2. So I went ahead and reduced the slope, and I went ahead and graphed it over here. So I graph at my y-intercept b, and then I go down 3 and to the right 2. So again, let's pause the video and work number 6 on your own. And then when you're ready to check your answer, go ahead and hit play again. Okay, so here's number 6. Went ahead and simplified it, so it's 3/4 x plus 2. Begin at 2, and then you rise 3 and over 4. Okay, so hopefully this lesson was not very confusing for you. It should still be review, but if you're confused about anything, please report that on your WISC, and we will talk about it when you get to class tomorrow.